All right. Well, Fred, we're learning how to name and form ionic compounds. And now we have to introduce what we call our polyatomic ions. This is some, not all, the polyatomic ions. And this is a good representation of many of them that we'll be using. This list is on the back of your periodic table, right? Have you seen that list?
Yeah, I saw it around.
Okay, so here it is.
Yeah. All right, yeah, I got it.
Now, many chemistry classes will ask you to memorize this list, which is great. However, I feel like it puts it in the wrong place in the brain. And the place that we want it to be in the brain is the one that you'll always remember it going forward. And I think that the only way to make that work is if we use it over and over and over. So here's another rule for this class. Every time you come across a polyatomic ion that you don't know, you have to get out your chart, look at it, look at its name, look at its charge, and understand how it's being used in the compound that you're looking at. Okay? So, these are our list of polyatomic ions. Sometimes we'll have scenarios where we can't use the list because we don't know the name, or it's not on that list because that's not a complete list. It's just some of the more obvious ones or more used ones. So like this kind of a question here says, a platinate ion forms an ionic compound with sodium as follows, and we need to know the formula of iron 3 platinate.
How can we do that?
Well, if we look at the sodium platinate here, what does that tell us about the charge on the platinate ion?
Well, the platinate ion's not on the polyatomic chart.
You're right, it's not on that polyatomic ion list. But if there's 3 sodiums needed for every platinate, what does that tell us about the platinate?
I don't know.
Well, do you know what the charge on the sodium ion is?
Oh, it's going to be a +1, huh?
That's right, it would be a +1. Therefore, if I need 3 of them for every platinate, what does that tell us is the charge on the platinate?
Must be a -3.
That's right. So PtO4 has a -3 charge. And now, iron 3 platinate, what is the iron 3 referring to?
3 irons?
No, that's not what the 3 refers to. We only use that little Roman numeral in between the metal and the anion, the cation, the anion, if we're dealing with a transition metal.
Oh, right, the transition metal. Because the transition metals are the ones that might have different kinds of ions they could form.
That's right. We can have a +2 charge or a +3 charge on our iron ion, right? So if this is iron 3 platinate, it's not telling us that I have 3 irons, but it's telling me that I have the +3 charge on the platinate, or on the iron. Therefore, the ratio between the iron ion and the platinate ion is a 1-to-1 ratio, okay? So the answer here is going to be C.
I got it.
Very good. So here's another example. What metal would be a reasonable candidate to replace M in this ionic compound that forms with phosphate ion?
Phosphate ion. Is that on the list?
Well, let's see. Let's bring it out here. Here's our list. Here's the phosphate ion.
Okay, so it has a -3 charge. And there's only one of the metal. Can I see the periodic table?
Sure.
So sodium and lithium are in the first row. So they're going to have a +1 charge. So you would need 3 of those for every phosphate. And here it's just saying 1 metal. So it can't be sodium or lithium.
So you're saying sodium and lithium in the first column here have a +1 charge in ionic compounds. And if phosphate has a -3, let's do some writing down here. Phosphate has a -3, PO4 -3 charge there, right? And this metal apparently has, you've decided, a +3 charge?
Yeah, because there was just 1.
Right, so if there's just 1, it must have a +3 charge. So I guess we're trying to find out which one of these could have a +3 charge. Sodium and lithium, you said, would only have a +1. What about magnesium?
Where's magnesium? Magnesium would just have a +2 because it's in the second column.
All right, so we're looking for something that's not a representative element, huh? It's going to be over here or over in our post-transition metals.
Scandium. Scandium's number 21, SC.
Very good. So this one could have a +3 charge then. So that is a candidate, a possible candidate for this combination. 1 scandium for every 1 phosphate.
Yeah.
Okay, good job. Great. Now we're going to talk about naming molecular compounds. Another name for a molecular compound is a covalent compound. Covalent compound. Covalent is referring to two atoms that have the same kind of condition in terms of their need for electron density. Both of the valencies, or all the nonmetals, are in the same condition. They want to gain electron density. All right? So when we name covalent compounds, we use the mono, di, tri, these Greek prefixes. These Greek prefixes, you've probably heard of most of these. There's some that you haven't, but we want to kind of remember them. And I'll give you a couple ways to remember the hard ones. So tetra, I think, is a hard one. But the game Tetris, I don't know if you've ever played Tetris. Have you ever played it, Fred?
No, I never play video games.
Why not?
Well, they require thumbs, and I just don't like to play. I don't want to talk about it.
Okay, all right, that's fine. Well, maybe you could watch your roommate play Tetris.
Oh, I can do that.
Good, because you'll see why Tetris, the game, has to do with the number 4, and that'll help you remember that tetra is 4. How about hepta? Have you heard of hepta?
No, I've heard of hexagon and pentagon, 6 and 5, but I haven't heard of heptagons or anything like that.
Very good. That's right. You haven't heard of hepta. And nona? Where have you heard of nona before?
Well, we said that nano was 9, so that's kind of similar.
That's good. And deca is 10. That's the decimal, right? Decade. Those are easy enough. Let me tell you something about the months of the year. October used to be the 8th month, and December used to be the 10th month, and November used to be the 9th month. But 2 months, August and July, were added and moved all those months back. So September used to be the 7th month, and that is one way that I remember hepta, because septa comes from a similar prefix for the 7th month. So September, October, looking at our months here, right? September, October, November, and December. That's where we get those names initially from the 7th, 8th, 9th, and 10th month. So that's one way I can remember hepta, nona, and deca. Okay. Now with these binary compounds, all you do is you take a compound like hydrogen chloride. That's just 1 hydrogen and 1 chlorine. Phosphorus pentachloride, 1 phosphorus and 5 chlorines, the penta. Triselenium dinitride. What would the chemical formula you think be?
Tri is 3 and di is 2, so 3 seleniums and 2 nitrogens.
Very good. Se3 and 2. Okay. Mono is always omitted if it's the first element. And if it's the second element, oftentimes it is, but sometimes it's not. So carbon monoxide is an example where we can't kind of limit it. We need to have it there, because if we don't, then we can't tell the difference between carbon dioxide and carbon monoxide. We would just call them both carbon oxide, right? So, and this is why we need these mono, di, and tri, is to differentiate between our different combinations that our nonmetals can form when they come together. This isn't the case with ionic compounds. If calcium comes together with oxygen to form the calcium oxide, there's only one way that it can happen. If magnesium comes together with nitrogen, only one way, so we can just call it magnesium nitride. Now iron, because iron is what kind of a metal?
Transition metal.
Yep, when iron comes together with a nonmetal, we want to call it iron 2 or iron 3, depending on what kind of compound it's forming. Iron 2 chloride, iron 3 oxide, right? Not to tell us the number of the other element, but to tell us the charge that's on our transition metal. Okay, very good. Now, let's see if we can name this compound.
SCl2, that's just, can you bring me the periodic table?
Yeah, let's bring it up here.
Sulfur and chlorine. Yeah, both nonmetals, so it's sulfur dichloride.
Very good. Sulfur dichloride, because they're both nonmetals, so we use the mono, di, and tri to name molecular or covalent compounds. HF?
H is an exception, but it's still a nonmetal, right?
That's right. So what do we call this?
Hydrogen fluoride?
Very good. Hydrogen fluoride. N2O5? Why don't you guys solve this one at home first? Make sure you push pause. Okay. What is it, Fred?
Dinitrogen pentaoxide.
Very good. So we got the 2 and the 5. Dinitrogen pentaoxide. And you see here that, again, we're not saying sulfur chlorine, sulfur dichlorine. The ene goes to ide. Fluorine, fluoride. Oxygen, oxide. Okay? All right. Which one of these is correct for nitrogen triiodide? All the folks at home, give it a shot. Which one is it, Fred?
It's non-metals, all non-metals, so it's a molecular compound, so it's Ni3.
Very good. Excellent job. Which one's correct here, Fred?
Should we wait for them?
Yeah, go ahead and wait for them. Push pause. Solve it. All right, ready? Tell us, Fred.
Oh, I think it's B as in boy.
Very good. Tetraphosphorus decaoxide. Excellent. Okay, can you name these compounds?
Yeah, the first one.
Well, wait. Hold on just a second. Let everybody at home give a chance to name them. All right, everybody take a chance at home. All right, here we go.
Sodium oxide and potassium oxide.
Very good. Now, what is this thing?
I have no idea. We need the polyatomic ion chart.
Okay, let's bring it out. Those are polyatomic ions, right? NH4.
It's at the top. That's ammonium, and ClO3 is chlorate. So is that ammonium chlorate?
That's right. Good.
Magnesium, what's that other thing? Oh, there it is. Acetate?
Yes, magnesium acetate. Very good.
These aren't polyatomic ions. Can you bring out the periodic table? So Cr is chromium. I see that. It's element 24. Chromium oxide. But because it's element 24, it's transition metal, we need a number, right?
That's right. So what number are you going to put on there?
Can I use the crisscross rule in reverse?
That's very good realization there, Fred. So chromium ion must have what kind of a charge on it in this compound?
It must be chromium 3 oxide.
That's right. It has a +3 charge. So chromium 3 oxide. Very good. How about this last one?
That should be, again, transition metal, so zinc 2 bromide.
Very good. Now, it just says zinc bromide here because there are some transition metals that do not form multiple charge states. But if you called it zinc 2 bromide, that would be just fine. So you go ahead and move forward with that. Okay. Calcium hydroxide. Can you draw the chemical formula? All right, take a second to draw the chemical formula for these 3 compounds, and then we'll be right back. All right, Fred, what's calcium hydroxide?
Calcium Ca, hydroxide. Is that on the periodic table?
No, hydroxide's not, is it? It's on the polyatomic ion chart. You see it there?
Oh, yeah, it's the third one. Okay, so calcium hydroxide is CaOH.
Like this?
Yeah, calcium hydroxide.
Okay. Want to check this out, see how we did?
Oh, no, yeah. Calcium has a +2 charge, so you need 2 hydroxides.
Okay, is that important?
Yeah, it probably is.
It will be very important. So we have to make sure we always think about the charges on the ions before we just write down the chemical formula. All right, copper 2 chloride.
The 2 means the +2 charge, so Cu with 2 chlorides because there's -1 on each chloride ion.
Very good. Copper chloride. Ammonium phosphate.
Can you bring out the transit? Or yeah, that thing.
Here it is. Ammonium ion on our polyatomic ion table. And then the phosphate ion.
Where's the phosphate?
You see it down here at the bottom? There it is.
So the ammonium was a +1, the phosphate's a -3. So you're going to need 3 ammoniums for 1 phosphate.
Very good. NH4 PO4. All right, some hydrates. Let's see if we can remember this.
I can't. I don't remember.
Well, all you do to name the hydrates is the metal, the polyatomic ion in this case, or the nonmetal, and then you say di for 2 hydrate, or hexahydrate, trihydrate. All right, see if you can do it. Go ahead and push pause. Take a chance. All right, Fred, help us out.
Well, that's calcium. The SO4 is on the polyatomic ion chart. Calcium sulfate dihydrate.
Very good.
This is cobalt 2. It's a transition metal. Cobalt 2 chloride hexahydrate.
Very good.
Iron. Iron's a transition metal. Iodide. Can you bring up the periodic table?
Yep, iodine. Here it is right here. So the iodide ion is a -1 charge.
Iron 3 iodide then, trihydrate.
Excellent job. Now, here's a good chance. What's the correct name for this compound? Give everybody a chance at home. Take the chance. Okay, tell us, Fred, what is it?
Copper 2 sulfide.
Copper 2 sulfide? Why did you say copper 2?
Because there's the 2 there.
All right. So, again, what is this number supposed to be telling us, Fred?
Oh, no, it's not copper 2. So, hold on, I got to think about it. What's the charge on the sulfur? Yeah, the sulfur. What does it do?
Let's bring up the periodic table here.
Okay, so it forms a -2 charge.
Very good. And
Copper there is, well, there's 2 of them. So if sulfide is a -2, and you had 2 coppers, then each copper must have a +1. Is that it?
that's right. So then what are we going to call this?
It's not copper 2?
No, because that 2 is telling us what the charge is on the copper. So this is going to be not telling us how many coppers there are or how many sulfurs. It's telling us the charge on each of the coppers. It's not telling us the collective charge. It's just the charge on the individual coppers. So it's going to be copper 1 sulfide. All right?
Okay, I think I got that. That'll be a tough one for me.
All right, last one here. What's the correct formula for ammonium sulfate? Everybody ready at home?
Okay, yeah, I got it. Ammonium, NH4, they're all NH4. Sulfate, the B and C is just sulfide, but sulfate is a polyatomic ion. It has a -2 charge, so this one has to be D.
Very good, because we knew that the ammonium is a +1 and the sulfate is a -2. This had to be the ratio. Excellent job. We're learning how to name compounds, which we won't be able to move forward without knowing how to name compounds. So make sure you do your homework on this.
Okay, I will.